All right, welcome back, everybody. Mr. Martin here. This is Mr. Martin's Math Corner. We're on 10.2. We're going to talk about these quadratics again, but this time we're talking about them in vertex form. So I'm going to show you guys how to move from standard form, which is very important to remember. Hopefully you lock that down, into vertex form. We can go the other way too. It's also good to see where things came from, right? But our main focal point is drawing this graph, and as always, using a table is very helpful. But I'm also going to show you this, and one of my favorites, this 1, 3, 5 method. All right, so let's take a look at our things to know. Let's do a little bit of recall. We got this standard form of a quadratic function. Remember, this is our x squared plus bx plus c, right? Some term, and some term. We got a quadratic here. Now, this new piece of information, this is what we call vertex form, and it is written as such. So kind of committing this little form to memory is helpful, but we still got to understand what these pieces are. So I'm going to label these out for you. Let's take a look at our first one. We have this A. All right, bam, that popped up like magic. Look at that. So this A value in our vertex form, I am describing this. This is going to be the same as our A value in standard form. So what we see here in our standard form, whatever value for A is, that's going to be the same thing for our A value here in our vertex form. Okay, and this describes two different things. It's going to talk about the shape of our quadratic, so whether we have a stretch or shrink, that's something you're going to learn about a little bit later. And whether our graph is positive or negative. And remember that positive or negative describes if something opens upward or downward. All right, so moving further left, okay, this parenthesis will always be there. This x will always be there, okay? Our next piece is this letter H. All right, so something's about to pop up right here. And shazam, horizontal shift. This is what that H value is. So this horizontal shift, what we're talking about is when this quadratic moves from left to right. Okay, and I put this little thing in parentheses here saying to think opposite, and you guys are going to see why as we go through a couple of these. So I always remember this H value to be the opposite, okay? And that'll make sense a little bit later. All right, let's go to our last piece. Okay, this is going to be our K value, okay? And what the K value tells us, drum roll, vertical shift. Okay, this tells us the up or down shifting values of our quadratic. And I put another little parenthesis here, just a little reminder. This is just something that helps me. If you find a way to help yourself figure out everything, go with that. But I always say always true. So whatever value I got, I keep that value. For my H value, I always do the opposite. Okay, and then down below we have this H comma K. This looks kind of familiar. This looks like an ordered pair, right? And this is actually our vertex. So the H is going to stand for our X value of our vertex. Okay, and then the K is our Y value. Super confusing, I know. That's just how math is. Let's roll with it. Okay, so when we talk about vertex form, these two pieces of that form, that's giving us our vertex, and knowing the vertex is super duper helpful. So let's go ahead and check out how to find the vertex when we are given standard form. So I gave you guys a couple steps right here, and yes, there is a little formula for you to remember. We call it negative b over 2a. All right, so I gave you these steps. The first thing is always make sure you're in standard form. Then this little formula here gives us the axis of symmetry. And remember, that axis of symmetry is the x value of your vertex. So let's trace back to remember when we first learned function notation. We said an ordered pair was the same as x comma f of x, right? Because f of x is the same thing as y. So we can say the same thing here for the x and y values of our vertex. The x value can be our negative b over 2a. And then step 3 says substitute your x value into your quadratic to solve for the y value. So the same thing with function notation. Our y value is f of whatever our x value is, and that is negative b over 2a. So function notation of the vertex would look a little something like this. So we could say function notation of vertex. All right. So I'm going to walk you through one of these and let you pause the video and do the other two. These are very, very simple, so you don't need me to walk you through all of them. First thing that is always helpful anytime is identifying your A, B, and C values. We have done this before. Some of us need to write them down. Some of us don't. Either way, I am going to write them down for you here. I always like to see them. So remember, we are looking for the coefficients. So my A value is a 1, my B value is a -8, and my C value is a +15. So I'm going to use this formula to find my X value first. And remember, anytime you substitute, always substitute using parentheses. So I have a negative, and then I'm going to put my B value, which is -8. And I'll put that all over 2 times my A value of 1. And then -8 is the same as +8. And 2 times 1 is 2. 8 divided by 2 is going to give me a 4. So this is my X value. So to find my Y value, right, I'm just going to simply plug this X value into my function here. So we got f of 4, and then we're going to do 4 squared minus 8 times 4 plus 15. 4 squared, that's going to give me 16. -8 times 4 is going to give me -32. Then I got plus 15. I crunch all those numbers together and I should get -1. Alright, and then my vertex is going to be these two values. I have my X value and I have my Y value. So I'm going to write that out for you here. Alright, there it is. 4, -1 is my vertex. Alright, go ahead, pause the video, try the other two on your notes by yourself. Come back, take a look, and see what you got. Alright, welcome back. So I crunched these out myself. And this first one, look at my ABC values. I wrote those down. I plugged those into that formula there. I evaluated, then I took my X and my Y value. So I got a -3 and a -1. And then on the second one, I have a -3 and a +3. Alright, so this -b over 2a, this is very helpful when in standard form to identify what that vertex is, and I'm going to show you why later, because that vertex is a very good point to start working with, especially when graphing. Alright, let's take a look at our next piece of information that we need to know, which is converting from standard form to vertex form. This is something that's very lovely, very fun to do. And I gave you this series of steps right here. First of all, it says find the vertex. We did that before in the last example. Then it tells you to substitute the A value from standard form into the A value. We talked about that in that diagram where I said the A is the same from standard and vertex. Then this is where I talked about doing that opposite. Choose the opposite sign of the X value from the vertex and substitute it into the H value of the vertex form. And then substitute the Y value of the vertex into the K value of the vertex. Let me go ahead and pop up vertex form on the screen for you guys so you can see it here. One moment. All right, bam, that looks lovely right there. All right, so we're going to just follow these steps. First thing, we're going to find that vertex. We know that our B value is +8, so we're going to do negative B value over 2 times our A value, which is a -1. Don't forget, if you don't see a number there, it is always a 1, but also pay attention to your signs. So now we got -8 over 2 times -1. That is -2. This is going to give me a +4. Okay, now I need to substitute this into my function right here so I can find my Y value. So we got f of 4 is equal to -4. Remember, I'm putting that 4 by itself in parentheses. That negative is part of the function. Alright, so we got +8 times 4. 4, and then -13. And this is going to give me 4 squared. So I got -16 plus 32. And then -13, and that is going to give me +3. So I got my vertex of 4 comma 3. Let's go ahead and write that down. All right, so we got the vertex written down, 4 comma 3. Now we're gonna do steps 2, 3, and 4, and it is simply just putting things in the place that they need to be. So remember, we are in function notation. So we got f of x, we got our equal sign. All right, that part we know. Then it says substitute the a value from our standard form. So what is the a value? Well, our a value here is a -1. So I'm going to put that negative. Remember, this is going where that a value goes. Do I need to put the 1? I can, but I do not need to. Okay, remember I told you that parenthesis will always be there. I told you that x will always be there. And then I said we're going to use the opposite of our sign for the h value. And the reason being is because we have this negative sign in there. So if we substituted this +4, right, if we put that in like that, what would negative times 4 be? That would be -4. So that's why our brains can look at this and say, oh, I'm going to put the opposite of this sign in there. I got this +4, so I'm going to put that as a -4. Okay, then I got my parenthesis. That is always there. That square is always there because we were talking about quadratics. And then the k value is the y value of my vertex. So I'm going to put that where the k is. And I said that one always stays true. We do not do the opposite. So here it is a +3. So boom, I'm going to put a +3. And I have successfully converted from standard form to vertex form. All right, go ahead, stop that video right here. Try the next two on your own. Watch me work this example out again if you need to. This one is really not too difficult. It's just a matter of following those steps. Find that vertex, then start plugging those values in. All right, pause the video, come on back, see if you got what I got. All right, great job. Hopefully you got the same thing. So here I found my vertex was 2, -4. Now let's take a look at what I did. I had an a value of 1. So if you look down here, I have the same value of 1. My x value of my vertex is a +2. I put it in here as -2. I got that squared. Then I had a y value of -4. It went in as a -4. All right, and this last one, I had an a value of 1/2. So I put that where my a goes. I had an x value of -2. Remember, for the x values, this h, we always do the opposite. So -2 turned into a +2. And then my y value is my k value, rings true every time. -1 stays -1. Boom, these are done. They are boxed up. So always, always, always have this form in front of you. It kind of helps act as a roadmap of where you need to put these values. The ones that are important to us are our a value, that x value of your vertex, and that k value. Because remember, our vertex is h, k. Very good. All right, let's take a look what we got next. We are going to convert from vertex to standard form. And this is something that we did many, many units ago. We are actually just evaluating. If we had something like this, look, what is my a value right here? Let's just do this for fun. My a value is a -1. What is my h value, right, in vertex form? My h value is actually a -2, and my k value is a -4, right? So my vertex would have been -2, -4. Because remember, this -4, the y value, that rings true. Whatever you see here is the opposite inside of your vertex. So that can be kind of fun to do. We're going to see that much, well, maybe not much later on. A little bit later on. Let's go ahead and evaluate this. All right, so we got f of x. I'm going to keep this negative out here on the side first, because remember, if I got a binomial squared, I need to do what to this guy? I need to say x plus 2 times itself, which is x plus 2 minus 4. And if you forgot already, this is what we call that sum of squares, right? Something times itself. So if we distribute this out, we would end up getting x squared plus 4x plus 4, and then we got the -4. Remember, the trick to this is your b term right here. Let me put that in green. your b term is always double that value. And then your c term is always this value squared. In this case, it ended up both being 4, but you get the picture. This was back in our Unit 9. So take a look at those special case polynomials if you want to recall how to do that. All right, so we are not done yet, right? We still have this negative sign, okay? Because this negative sign is distributing to this. We got to follow those orders of operations. So let's distribute this out. So we got negative times x squared, negative x squared, negative times 4x, negative 4x, negative times 4 is negative 4, and then we have the minus 4. We want to combine our like terms, and we are going to be left with negative x squared minus 4x, negative 4, and negative 4 is negative 8. All right, so that is how that looks. All right, let's go ahead and box that up. Ooh, that's a big border box. Okay. So I gave you the last two to do on your own. Remember, go ahead and square that binomial, distribute out your a term into that, and then subtract your c term or add your c term, whatever it is, and then combine your like terms. So evaluate the vertex form. Combine your like terms. All right, pause the video, come back, check the other two. All right, so this is what I got. I ended up with these two answers here. So I just want to touch briefly. Remember what I said. Let's try that trick that I tried to show you right here. This term right here. Did my middle term equal double that? What is double of 4? Double of 4 is 8. It sure did. And then my c term is this term squared. What is 4 squared? 16. Okay, so that's an easy way to get from here to here without having to do this. Okay, just a way to skip that. So let's try that again right here. Is my b term double of 3? What's 3 times 2? 6. Sure is. And then I square it for my c term. 3 times 3? 9. Very good. So this can be helpful seeing things in standard form instead of vertex form, depending on what you're trying to do. So it's good that we know how to get from one to the other. All right, now to the meat and potatoes. We're going to do a little bit of graphing. So I'm going to show you a couple things. All right, we can do these manually, of course. Most of the stuff in Algebra 1 we can do manually. If you have a graphing calculator, even better. But we do want to be able to know how to graph these by hand and by how to use a table. But the biggest thing when using a table is, and I'm going to write this here, which x values do I choose? All right? Because these graphs just go all over the place. Remember from the last unit we had, a domain of all real numbers. So the biggest thing that you want to think about is which x values do you choose? I'm going to give you a second to think. What would be the most important point on this graph? Think. Think about it. Take your time. All right, don't take too much time. It is the vertex. Yay, very good. If you got that vertex, oh, that's a horrible parabola. If you got that vertex, you know what other points you're going to use, right? And we know that we have what we call an axis of symmetry, so one side should look like the other side. So that is something very helpful to think about. All right, so I'm going to show you a couple things. I'm going to show you one, how to do this by hand or manually with a basic calculator if you need to use a basic calculator. And then I want to show you again on the graphing calculator. So I'm going to do these first two, walk you through, and I'm going to have you do the other two on your own. All right, so we said we wanted to find the vertex. Okay, if we are already in vertex form, that is quite lovely. Okay, because we have the vertex given to us. We got this piece right here, and we got this piece right here. So remember, this is our h, because we are looking for h comma k. Right? I'm just going to label this V so I don't have to write it all out. But we know that h is always the opposite of this sign that I see. So if I see a positive 4, I am looking for a negative 4. And if I have a positive 4 for my k value, when I say that one is always as is, it is the true deal, the real deal, Holyfield. So that's going to be a positive 4. So now I found my vertex. Super, super simple. And if this is my vertex, I know I'm needing points on the left and the right, the left and the right, the left and the right. So if I got this table right here, where do you think this vertex should go? You guessed it, smack dab in the middle. Negative 4, comma 4. Boom. That's a great place to start. Now I want numbers to the left and I want numbers to the right. So what is to the left of negative 4? That's going to be negative 5. What is to the left of negative 5? Negative 6. And then what is to the right of negative 4? That is going to be negative 3. And to the right of negative 3, that is going to be negative 2. So we are going to be looking for these y values. And it is as simple as plugging in that x value. So let's go ahead and do that. Negative. I'm going to put a negative 6 right here for my x. I got my plus 4. Square it. And then plus 4. So let's figure out what this is. Well, negative 6 plus 4 is going to give me negative 2. Negative 2 squared is going to be positive 4. And then I have this negative on the outside. All right, I'm going to work out this first one because maybe that's a lot to say. So negative 6 plus 4 is going to give me negative 2. Negative 2 squared is going to be positive 4. But don't forget, you got that negative on the outside. Negative 4 plus 4 is going to give me a big old 0. Okay, so it's helpful if you could do a little bit of mental math so you don't burn all through your writing room right here. I'm going to erase this. Grab some extra scratch paper if you need. All right, then we're going to do the next one. So we're going to write that in. Negative 5 plus 4 squared plus 4. Okay, I'm going to crank this out in my calculator, and that's going to give me a 3. Okay, then I'm going to do the next one, my negative 3. I don't need to do the vertex. We already know what that is. Okay, negative 3. So I'm going to do negative 3 in parentheses right here, plus 4 squared, and then I'm going to do plus 4. I'm going to crank that out, and I'm going to get 3. Oh, wait, well, what do you know? Is there a little pattern emerging here? Maybe. Let's see it. Negative 2 plus 4 squared plus 4. I number crunch these correctly, and I get 0. Oh, what do you know? If we take a look, let me highlight this. Boom, that's my vertex. Going to the left, we went 3, then 0. Going to the right, we went 3, then 0. Yes, there is a pattern, and there should be because we have this thing called symmetry. All right, so now let's go ahead and graph this. I like to graph my vertex first. So I'm going to find negative 4 comma 4 right up here. And then I just go through and do all the other ones. So negative 6, 0. Negative 5, 3, and then we got negative 3, 3, and negative 2, 0. Oh, that's kind of ugly. Let me fix that. All right, and then I can go ahead and start drawing my parabola. And hopefully yours look a little better than mine. Remember, try to make this rounded. They should not be a V. They should not be a sharp angle like that because that is actually an absolute value function. Very, very different. Okay, so this is how we can do it using a table. Now, the reason why I want to show you again on here is because I want to talk about using the graphing calculator. So let me pull that up for you one moment. All right, hopefully you can see this well. So first thing we need to do, remember, let's find that vertex. We know that that vertex is negative 4 comma negative 3. So let's plug that in. And then we know we need two values to the left of that, so we're going to do -5 and -6. And then we know we need two values to the right, -3, -2. So that part's the same. You got to figure out what you need for your table. Okay, but remember, we can use our function here by typing it in. So let me clear that out. So we hit that y equals button. Let's go ahead and pop this back up. And then let's actually enter this function. So we're going to do parentheses x plus 4. We're going to square it. And then we're going to do that -3. And if you remember from before, we have that table function. So we can hit second and then table. Okay. If you are on ask, then it's going to ask you to plug in those values. Let's go ahead and change this back to automatic. So remember, we do that with the table set. If you need help with this, reach out. I will teach you how to do it again. This is my independent variable. Instead of having it ask me, I just want it to be automatic. So I hit enter on auto, then I go back to my table. And then now I got all these x values. So let's go ahead and find our -6 all the way down to -2. All right, -6. There we go. So we can plug these in. So -6 is going to be a 1. Okay, that's going to disappear. -5 is going to be -2. -4 is -3. That lets us know we did it right. And then we got this -2 and this +1. So remember, we do have this pattern here, just like we did here. So you really only need to find 2 to the left. The 2 to the right are going to be exactly the same. Or, you know, you could sit there and crank those numbers out down here by hand if you don't have that calculator. And remember, you can always use a basic calculator like this. It will get the job done. All right, so let's go ahead and go back full screen. 1 second here. All right, I'm back. So let's go ahead and graph this. We got -4, -3. That is my vertex. I got this -6, 1, -5, -2, and then -3, -2, boom, and then -2, 1. All right, I will try to draw this the best I can. Remember, don't forget to draw your arrow tips. Mucho importante. All right, go ahead, pause the video. I'm gonna have you guys do the two, or actually, don't pause the video. Let's walk through these. These ones are in standard form. Can we easily do these by using a table? We sure can. All we got to do is find that vertex. So let's go ahead and do that real quick. So we got -b, right? So -4 all over 2 times my a. -4 is +4. 2 times -1, -2. 4 divided by -2 is -2. Let's go ahead and plug this in. Let's do -2 squared minus 4 times -2. Then we got -6. This is going to be 4, so -4. -4 plus 8. -4 times -2 plus 8, if I'm correct. And then -6. And that's going to give me -2. All right, so that is my vertex, -2, -2. All right, now I'm going to have you pause the video because you know what to do. We found the vertex. All we got to do is figure out our tables. Go ahead, pause the video, come on back. All right, welcome back. So on this one, I went ahead and graphed that. We found that vertex together. Now take a look at this last one. I found the vertex, -3, 1. We got some giant numbers here. So if you took a look at this graph, make sure you always recognize how the axes are numbered. Look, these are going by 2s. So this first point, -5, -15, make sure you are going where those points are supposed to go. So a lot of these had to be cut in half to get those odd numbers. So we have this type of skinnier quadratic. Also something to remember for an upcoming lesson. All right, and then last but not least, my very favorite, we have what we call the 1, 3, 5 method. Okay. So with this, the 1, 3, 5 method, there is a small stipulation. Okay, I should actually call it the 1A, 3A, 5A method. So you might want to write that down on your notes. Okay. There is a very unique pattern that goes on in these quadratics, but we do need to use our A value. Okay, so what we do, the first thing is we find the vertex. So 1, vertex. Let's plot that. Plot that. All right, so if this is +1 and this is +4, remember we are always doing the opposite of this. So this is going to be -1, +4. Okay. Then step 2, it is always to the right by 1. Okay. So we're going to go to the right by 1. Okay, and then we're going to find our 1A value. So we're going to take 1 times our A value, which is our A value right here. This is a 1. So we're going to do 1 times 1, and that is going to give me a 1. So that means I will go up 1 unit, and this is my next point. Okay? So it's always to the right 1, and then up 1A, 3A, and then 5A. Okay, so now we're going to go to the right one more time, but this time we're going to go up 3A. So what's our A value? That is a 1, so 3 times 1 is going to give me a 3. So we're going to go up 3. 1, 2, and 3. Okay, then step 3, we can draw our axis of symmetry. Draw axis of symmetry. Sorry, my handwriting is really bad right now. So if we put our imaginary line here, okay, you don't actually have to draw it. I could say mentally draw it. But we know that these points are equally spaced apart because they are symmetrical. So let's go ahead and remove these, and then we can plot them. So this is our vertex. So this point right here is 1 hop away from the axis of symmetry. Let's go 1 hop away over here. And then our next point is 2 hops away. So we're going to go 2 hops away on the other side. And then boom, we're done. We have all we need to draw our parabola. Sorry, we should have done 5A, but we would have went off the graph. But 5A would have been 5 times 1, and that would have gave us 5. Hence the 1, 3, 5. But the reason I say 1A, 3A, 5A is because we don't always have a 1 here. If we look at this example, what is our A value? Here, our A value is -1. So let's find our 1A, 3A, and 5A values. So we got 1 times -1, that's going to be -1. 3 times -1 is going to be -3. And 5 times -1 is going to be -5. So remember, it's always this right one, and then your 1A, 3A, 5A. But in our case, instead of going up, we are going down because we have this negative. So let's plot that vertex. So our vertex is -1, comma, -4. And then I'm going to go to the right one, and then I'm going to use my 1A, which is -1. So it's telling me to go down. Then I'm going to go to the right one, and I'm going to use my 3A, which is telling me to go down 3. 1, 2, 3. Boom. Okay. Do I need to draw that line? I don't. I can just kind of see it right here, so I know this is 1 away. I'm going to go 1 away to the left. Here I'm doing 1, 2. I need to do 1, 2. And boom. And that's it. It's really simple with that 1, 3, 5. Okay. I'm going to do the next two with you guys because, I don't know, I feel maybe this might throw some of us for a loop. So let's just stick with it. Here we go. We got some different A values. This is going to be very good. So first thing, let's plot that vertex. If this is negative, we do the opposite. This one we do true. So opposite of -1, +1, -2. That is our vertex. Very good. Okay, we have an A value of -2. So let's do our 1A, 3a, and 5a, right? What is 1 times negative 2? That is negative 2. 3 times negative 2. That is negative 6. And 5 times negative 2 is negative 10. So if you see here, we went 1, 3, 5, and we also went negative 1, negative 3, negative 5. In this case, look, we have a negative, so we're still going negative, but this 2 made everything double. Instead of 1, 3, 5, we got 2, 6, 10. Okay, but that pattern is what is sticking true there. So we start from that vertex. We always go to the right one, and this tells us whether we go up or down and how many. And this one's telling us to go down 2. So right 1, down 2. Then we're going to do right 1 and down 6. 1, 2, 3, 4, 5, 6. We could go right 1 and down 10, but we would be off the graph. So then now we want points on the other side, so we hop 1 to get to the middle, hop 1 to the left. Hop 2 to get to the middle, hop 2 to the left. 1, 2, 3, 4. Boom. And then we can draw this very beautiful looking quadratic. All right, I think you guys got it. I want you to pause the video, come back, try this last one. All right, welcome back. Hopefully you got the same thing I did. I got my 1a, 3a, 5a was negative 3, negative 9, negative 15. And if you remember from the last section, the anatomy of a quadratic, remember, this stuff should be letting you know that a value says we're negative. Negative means we're opening downward. These look like they are good to go. All right, so go ahead. Please try the practice. It takes a little while to get fluid with these. All it takes is practice, practice, practice. Remember, ask a friend, ask a teacher, ask a foe even. Hey, man, you don't like me? Help me with this math. All right, that is all I have for you today. It's been a blast. I will catch you guys on the next one. Hope you enjoyed it. My apologies for it being so long. I'll try to make these shorter as we move along. But, hey, I still like talking to you guys, so that's why they're a little bit longer than they would typically have to be. All right, I'll catch you on the flip. Peace.